Okay, so here we're going to go over the final part 2 review. The goal of this is just to kind of skim over all these little problems, and hopefully I help you with some little steps or nuances on how to actually do these problems properly, because again, these problems are nearly identical to the ones you're going to see on the exam. So really the process stays the same, but the problem itself changes a little bit. So please try to go over these solutions, and I hope that you're practicing them, and you should be fine on the exam. So let's start with the number one, evaluate your work. So first and foremost, evaluate. All right, you should always end up with a 0, negative right 2 over 2, 1/2, etc. So just a quick pointer out here, 3 over 2 is, if you notice, it lands on the terminal. So this is 0, pi over 2, etc. So 3 pi over 2 is down here. Anytime you end up in one of these little spots right here, just draw this graph and then go ahead and write the coordinate. And the coordinate is always going to help you solve this part right here. So right here we're looking for cosine. So what's cosine? Remember, cosine is represented by x, sine is represented by y. So therefore, all we care about is this one right here, because we're talking about cosine. That's how we know this answer is 0. Okay, so keep it simple. Another trick is here, if we look at number, or letter A rather, we have pi over 4. What's pi over 4? 45. How many of them? Times 5, right? So if you do the math, that comes out to 225 degrees. That ends up being here. But you already know that at the end of the day, it's a 45. So if you notice, I didn't do something here on the solution. It didn't affect me, but I didn't write it on the solution here. Not solution, rather, this graph is that this should have been a -1 here, right? And I didn't do that. But again, we're talking about sine, so it didn't affect me. So down here, all I got was -1 for y, because remember, you could always solve this by putting y over r, right? And my y is -1, and my r is radical 2. So if you notice, that's exactly what I put here, and we're done. And you do a similar process for A through C, or D rather. So that's all that's necessary. That's why it's important to try to draw these axes and fill them in as you go. Again, this is called sum and difference of cosine, right? Sum and difference identity of cosine. I think the important part here is to really get this down. Please get this down. This is not going to change from the exam. It will be nearly identical again. So if you notice, theta's here, theta's the first one here, right? Pi over 3 is the second one, it's right here. And the same thing goes on this side. Theta first, pi over 3 second. Just note that if it's a plus in here, it's going to be a minus out here, okay? Now, if you notice, cosine pi over 3 and sine pi over 3 are literally a special right triangle, which is 60 degrees. So the question is, do this real quick, right? That's rad 3, 1, and 2. So for cosine, it's going to be 1/2. And for sine, it's going to be, or sine pi over 3, it's going to be rad 3 over 2. So if you notice, this equals this. This equals 1/2. This part right here was obtained from, well, what does sine theta equal? -2 over 3. That's exactly what we have here. We replaced it with what it equals. The only one we have to work for is this one. So all you do is, please take this together with this cosine is less than 0. Draw this part right here, and it will literally give you this negative radical 5 over 3. Now, if you notice, I made a mistake. I put -5 up here. It really should have been negative radical 5. I just didn't put the radical. But if you really follow the steps, you need to confidently say, oh, you know, Mr. Godino just forgot the radical part. Don't second guess it. You know, I make mistakes too, and that's what happened. And then afterwards, you just literally multiply these across. That's how we got this. And over here, that's how we got this. But again, it should have been radical 5. Or negative radical 5. And as long as you get to this part, chances are you'll get full credit. Cool? All right. This last one here, sine, it's tangent to, and then if you notice, this part right here is really theta. Okay, so that's how you get the tangent to theta formula. First thing you should always do is just write it out. Now, if you notice, you don't have tangent theta. You don't know what that is. You have inverse of sine. So the question is, how do I get that? It's actually very straightforward. This still equals y over r. So y is 5, r is 6, and that's exactly how we put it over here. It's first quadrant because it's positive. You have to be careful with sine. It only exists between negative pi over 2 to, I said negative pi, sine, I think, but inverse sine, it only works from negative pi over 2 to pi over 2. So if you do the Pythagorean theorem, you end up with this side being radical 11, and all you got to do is just plug it in. You really just solve this right here. What is tangent theta? Well, let's look over here. Tangent theta is y over x. Y over x. Okay? And that's really what you care about right here. Why? Because tangent theta equals this, and this is what you're going to use. So instead of tangent theta, we have that. Instead of tangent squared theta, we have 5 over radical 11 squared. And we do the math. We need to subtract this down here, but we need common denominator. So if you notice, that's why we did this over here. And I hope you follow along. If you get to this step here, you'll get all, if not most, of your points. So don't get too caught up with this over here on the right-hand side. It's great if you can do it, but again, you shouldn't be wasting your time considering the amount of problems you have to get done. Cool? I hope this helps. Now, obviously my answer is a little wrong, or at least it could be, because remember, I was like thinking I made a mistake here, but I actually made it up here. No, so this problem should be correct for the most part, and look it over. Now, let's move on to this side. This actually is a little important over here. So what I really want to capture is, look at all these right here. They're inverse functions. I do want to really quick capture the fact that inverse functions do have a range. For example, sine was from negative pi over 2 to pi over 2. Inverse cosine is from 0 to pi. Did I write that somewhere? Right here. Inverse cosine range is from 0 to pi. So it really only works from these two quadrants. Let's go back here. Sine only works from these two quadrants, from negative pi over 2 to pi over 2 on top. And then the last one, it's tangent, and tangent is the same thing as sine as far as values, right? Negative pi over 2 to pi over 2. However, it's not closed. But know that for the purpose of this exam, the fact that it's not a bracket is not going to change anything. Just be careful with the fact that, like, negative 1, right? Remember that y over x is still the thing here. So what is y and what is x? Well, remember that this is really over 1. So y is negative 1, and then x is 1. So that's why I put x1, y negative 1. That means it has to be in the fourth quadrant. And I finish off with radical 2 because this has to be a 45-degree triangle. And then I could use that. So what reference triangles is? Pi over 4. But where is it at? Because it goes down, it's got to be negative pi over 4. Let me just clarify this. It's not, let's just say, let's do this together. Pi over 4, 2, 3, 4, 5, 6, 7. It's not 7 pi over 4, because 7 pi over 4 means you had to have done this. But remember, tangent only exists between these two right here. So you couldn't have gone past this pi over 2 mark. Otherwise, it's undefined. Therefore, that's why 7 pi over 4 doesn't work. It has to be just, boom, do that. That's negative pi over 4. That's why that is the answer right here. And that's pretty much the gist of all these problems from 4A, B, C, D. There's quite a few. So be careful. There's going to be a couple on the exam. A, B, C, D, I, E, F, G, H. Cool. This one right here, we talked about this in class. This is one of the problems that was most missed on test 2 or 3, whenever you had it. So just a quick reminder, keep it simple. If you notice, all I did here was rewrite it. And then I literally just plug in stuff here. So the 2, 2, and the minus, minus, and then I literally plugged in for V and W. I plugged in the actual V and W vector right there. Okay? So then you do the math, you distribute, make sure you distribute to everything. So negative will make this a negative 4i, but if you distribute it to the second term, that's positive 2j. That's how we got this over here. Once you do the math, you'll get this over here. These little dashes down here just mean, hey, combine like terms. And then we end up with this key here. Now, what comes after is very important. Absolute value bars, if you had absolute value bars, it'd be negative 6, which converts into just 6, positive 6. Now, the way magnitude works is it converts into you squaring what you see, but inside you do you square root what you see, but inside you do the negative 6 squared, which comes from here, and then the 8 squared, which comes from here, and you do the math, and you should get to this solution here. Keep it simple, keep it simple. Let's go to the last page real quick. We did just watch the previous video. I showed you how to solve this one here, but again, it's the same process, and we just did it on this side. That'll be it. This is a lengthy problem. I think it's worth 4 points. Is it worth doing? Yes. But again, don't get caught up too much on the details. Try your best. The way you can do that is repeat doing this problem after you have watched the video to make sure that you understand each step along the way. And that's pretty much it. That really is the conclusion of this. I hope sort of going over these problems helped. If you have any questions, please email me, and then I'll try to respond as soon as possible.